Hello everyone, and I welcome you all again in this operating system playlist. So this operating system playlist is going on my channel, and this is the next part of that. In previous video we have discussed about the process data structure, as you can see on my notes. So I think screen is visible to all of you. So from my notes I taught you about the process data structure. Okay, and see, these videos are basically, you understand them, you understand the concepts. Okay, and these handwritten notes you are going to get definitely for free. Okay, no charges for that. You will get it basically for free. So what you have to do basically, what your approach should be, that just try to understand the concepts in these videos, and after that just refer these notes, and you can just refer these notes, and you can just read the definitions and all that. After understanding, listen, after understanding the concept which I will be dictating in the video, after that you just need to go through the notes. Okay, then you will get the clear understanding of a particular concept or topic. Okay, so in that way I am teaching you operating system, and I think up to now you do not have any doubt, or you have all things clear which I told you. Okay, if you have any doubt or any suggestion, any feedback, so I will definitely welcome it. You can mention in the comment section, so can definitely go through your feedback or suggestion. Okay, if there's some changes you need, or you need that I need to explain in Hindi or English, or just I will welcome your suggestions. Okay, so in previous video we have discussed about the process data structure. We have seen that we have two process data structure, that is process table and another one is PCB. And today's video we will discussing about the most important topic, that is context switching. Okay, and I will give you the better understanding, or you can say clear, crystal clear understanding, okay, about that context switching, what it basically means. Okay, so let's see context switching what it is. Just now read the definition that I have written in my notes. See, I have not written any bookish definition in my notes. Getting? I've not just made these notes from any kind of book. Yeah, I definitely refer the book. I just refer the book just to get some important points, or some to get extra content to make my notes rich. Okay, so but the definitions which I wrote in my notes, they are not directly copied from the book. Okay, or they are not same as the bookish language. Okay, they are written by myself, or from an internet, or from where I found that this definition is easy to understand, easy to learn, easy to remember. Getting? So let's see what is this context switching. So context switching, as I have written, that it basically occurs in multi-threading. Let me take a pen. So here it is context switching. Okay, let me take a pen. Okay, so here it is context switching. Okay, so context switching is basically occur in multi-programming and multitasking operating system. Okay, this is you can say a general point, but what is context switching we will discuss. So when a CPU has to switch a process from running to ready or wait, then it is no then its context, sorry, then its context, or we can say state. Context is also known as a state. Context or state is saved in its own PCB, because when its execution time comes, so CPU resume the process where it left. See, if you do not get, I will tell you what happened when CPU basically executing the processes. If a particular process, if CPU has to switch a particular process from running to ready, getting, from running to ready or wait. Okay, then what happened then, when basically process is switching the process, particular process, from a running to it ready, or you can say a wait state, then its context, or in simple language you can understand, then its state is saved in its own PCB. PCB, I told you, process control block, I told you in previous video. If you have not watched it, just go through and you will definitely understand what is this PCB. So what happened, its context, or we can say its state, is basically saved in its PCB, that is process control block. Now, because now why it is saving, why its context or why its state is saving, because when its execution time comes again in the future, so CPU can resume the process where it left basically. Getting my point? Are you getting? Just try to understand. I'm telling you in a very simple, very lenient way what happened. Just forgot what is context switching, forgot. Okay, just let's understand the scenario. Let's understand the scenario. What happened when CPU is basically executing a particular process. Okay, and now this process, due to some like input output task or due to some high priority process, now this process has to shift or has to switch, process has to switch into a ready state or a wait state. Listen, process is in running state. Now, due to some input output or due to some high priority process, now CPU has to switch this particular running process from its running state to its ready, or we can say in wait state. It can be go into ready or it can go into wait state. Okay, and its context, or we can say its state, is saved in its own PCB. Why? Because whenever, like, see, if a input output operation came and then the process which is currently executing, it has to be switched. Okay, now its state will be saved. Why? Because process, like if we have a process P1, okay, like if we are talking about a process P1 that is executing and now it has to be switched from running to ready or wait state, but the P1, that particular process which is currently executing, has completed its execution up to 20%. We say like we have overall 100% execution. Now it's this P1 has completed its 20% of execution. Now the context, or we can say the state of that process P1, the process which is currently executing, the state is will be saved into its own PCB. Okay, why, how it will be saved? It will be saved like that this P1 has 20% executed, and now whenever it come into the future again, so don't start from the scratch or don't start from the 1%. Just start after the 20%. 20% has already done. Now you have to start after 20%. Okay, getting my point? Whenever it comes again in the future, so just don't start from the 20%. Start from the after 20%. Okay, only 80% then left. Getting my point? So that's why it is it is saving its state, or we can say context, and in where it is saving, in its own PCB it is saving. Getting? So that whenever it comes in the future, and it is definitely that it will come in the future. So whenever it comes into the future, so the process, sorry, the CPU can start its execution or resume its execution where it left. Basically from 20% it left, so it will start from the same 20%. It will not going to start from the scratch from 1%. Okay, no, it will be going to resume that, not restart. Getting my point? It is going to resume that process, not restart that process. Now this complete process is basically known as context switching. Getting? Simple, very simple. Context switching, you get? Context basically means the state, and switching, this context switching, you I think you have a clear cut idea now. Okay, the process, the CPU is switching a process from its running to it ready, or we can say a wait. Okay, they are both are different. Okay, if you have not watched the life cycle of this CPU or life cycle of process, so just go through it. Ready, wait, they are basically different states. Okay, so when a CPU switch a process from running to ready or wait state, okay, its context or state is basically saved in its PCB. Why it is saving? Because if this process came into the future again, so it can resume from the where it left. Basically it can start its execution where it left basically. Okay, and this process, this complete process, is basically known as context switching. Now basically the question arises, when context switching? I told you, but I told you, that I have written each and every point in my notes. Okay, so see, these notes are very much helpful. Just go and refer them. You will definitely get the good marks in exam, and you will definitely get the feel of the concept, so that you can also crack the interviews. If this operating system asked in your interviews, you will definitely crack it. And I promise you that if you understand the concept, you read the notes, you will definitely get the good marks. Now, where it basically occurs, when context switching, if a high priority process came, or if we are moving from user to kernel mode, or if we are moving from kernel to user mode, from if we are moving from user to kernel mode, or if we are moving from kernel mode to user mode, vice versa. Okay, then this can happen. Or interrupt, if there is any kind of interrupt, system call. Okay, system call we will discuss in future, in detail we will discuss. And fourth, I told you, input output event. So this is basically context switching. Now let's see what are the operations on process. This is also a topic mentioned in your syllabus. In most of the university syllabus, it is mentioned that what are the operations on process we can perform. So operations on process basically we can perform two types of operation. First is process creation. First is process creation, that process, a particular process can be created. So that first is process creation, we will discuss in detail. Another one is process termination. Now process has created, it has executed, it has done its task, or like you can say it has done its task for for which it is created, it has completed its task. Now there is no need of that, so then now just destroy it. So that state is known as process termination. We'll discuss in detail. Okay. So process creation, basically a process may create several new processes via create process system call. Okay. If we have a particular process that can create a multiple further processes with the help of a system call, that is known as create process system call during the course of execution. Okay. Now creating process is called parent process, and the new process are called or children of that process. So the process, the particular process which is creating a further new processes with the help of a create process system call. So the process which is basically creating, that is a parent process, and the new processes which are created, that are known as children of that process. It is very simple. Okay. Each of these child process can further create a new process, forming a trees of processes. Okay. See here I have drawn a tree. See, this is a P1 parent process, which is using a system called create process, is creating now the process P2, P3, P4. Now these are the child of P1. Okay. And now this P2 is further creating a new processes. So it is a kind of making a tree, it is making a trees of process. Okay. It is forming a tree of processes. So this is process creation. Now process termination means like process has completed its task and now it need to be terminated. So process terminated when it finishes executing its final statement and asks the operating system to delete it by using the exit system call. See, create process system call is used to create the processes, and now exit system call will be used to terminate the process. At that point, the process may return a status value that is typically an integer to its parents process by the wait system call. Okay. Now, whenever we are terminating, so that particular process may return a some kind of status value, and basically it's integer. Typically, it is integer to its parents process with the help of a system call, which is wait system call. Okay, so you just need to remember that process creation we use create process system call, and in termination we use exit, wait, and all that. Now all the resources of the process, including physical, virtual, open files, input output buffer, deallocated by the operating system. So it is obvious that a process, it basically created for some kind of execution. Now everything execution has been done, so all the resources which were allocated to that particular process will be deallocated by the operating system. So this is about process termination. Now there are some important points that we will discuss. The termination can be done or can be caused by the parent process to child process by appropriate system calls. See, we are discussing that the process can create further processes, and all that. Now, the termination can be done by its own parent. Getting my it is looking like awkward if we are saying it is it sounds very abnormal that a parent process would kill its own child. Yeah, it can kill. Why? We will discuss. In note you can see only a parent process can cause the termination or can kill its own child process, otherwise every process will kill to other processes. Getting my point? Only, listen the word, only a parent process can kill or destroy its child process, or terminate, we can say, its child process, no any other. Why no any other? Because if like this every process will kill to each other, okay, that will not be a case. And now it is sounds very abnormal, or like it is very you are thinking that why this process, the parent process, will kill its own child. So see, now this is in the form of question. Now the answer came in front of you. Child has exceed, first point, why? First point, we are discussing that why parent might kill its own child process. The first point is child may exceed its usage of some resources. Getting my point? Child has exceed its usage of some resources. Like it was declared earlier when child was created that child, you have to use only uh, two resources. You have to use only two resources. But now child, earlier child agreed, yeah, that okay, my parents, I will be using only two resources. Okay, but child has done something wrong, or I think his mind has changed now. Now child has exceeded its limit from 2 2 4 or 3, okay, or 2 5 we can say. Now child is not using 2 resources, it is using 3 resources, it is using 4 resources, huh? Okay, getting my point. Child is has exceeded its uses of some resources, so at that point of time parent has no any other option, and parent will definitely kill the child. Getting. Second point, the task assigned to the child is no longer required for the thing, for what cause, for what task the child was created by its own parent. Now that particular task is no longer required, so there is we don't require execution, so we don't require child. So at that point of time parent can kill. Third point is parent is existing or terminating, so operating system will not allow child to continue if its parent at that point of time. Okay, when parent is also terminating, so if parent is not there, so what will be the child will do? Child will not do anything if its parents is not there. If a parent is terminating, so child will also need to leave. Okay, so at that point of time parent will kill. So this is the case where parent might kill its own child process. So these are some points that you can understand, that whenever the parent can kill its child process, or only parent can kill its child process, no any other process can kill. Getting my point? So in this video we have discussed about the context switching and operation on processes, that is process creation, process termination. If you have any query, if you have any suggestion, I'm again telling you, if you have any kind of suggestion, please let me know in the comment section. I will definitely welcome them. And till then, thank you.